Classify, add, and subtract polynomials. All right, today's lesson is full of definitions and then a quick lesson on adding and subtracting polynomials. Okay, so a polynomial is an algebraic expression that consists of variables, coefficients, and constants. So what is a variable? A variable is a letter, any type of letter. X, 2x, right? X, sorry, not 2x, y, a. Any of those things are called variables. Coefficients are the numbers in front of x or the variable. So if I have the variable x, the number in front of that would be 3. That's coefficient. If I had a y and the number I put in front of that was nothing, we need to know that the coefficient is 1. Okay, so that's one of the ones that's the biggest mistake that most students make, is that the coefficient is the number in front of the variable. And then the constant. A constant is a number by itself, like 6 or 12 or even -3. All of those are constants. A number without a variable attached to it. Okay. Things that are not variables. It's very important that we know this. Things that are not variables. I'm going to write that in blue. Not. Example of that would be 1 over x. If we have a variable in the denominator, this entire thing is no longer a polynomial. If I give you 3x to the -2, well, if you recall from our previous lessons that when we have a negative exponent, it changes it to a fraction. So that's a fraction, and we're not allowed to have variables in our denominator. What else? If I gave you something strange like the square root of 2x plus 3x minus 1, this is not a polynomial because of the square root. So again, not a polynomial because of the square root, not a polynomial because of the -2, and not a polynomial because the x is in the denominator. So once we decide what a polynomial is, we actually get to name them. We get 2 names from the polynomials. You have a first and a last name like most people do. So do our polynomials. They have 2 names. The first thing they get their names from is from their degree. A degree is the exponent. So if we look at the highest exponent, and that's how we decide our names for the first part of the polynomial. So if the highest exponent, I'm going to start in the middle. Most of us are used to quadratics. It's by the time you get to algebra 2. Okay, and so a polynomial that has a exponent of 2x squared minus 3x plus 1, right? That's a polynomial. The highest exponent here is 2. We call that a quadratic something. And we're going to talk about the next part. So if the highest exponent is 2, then that's called a quadratic. Another one that you probably seen a couple times is something that looks like this. X, I'm going to go with 3x minus 4. Now, the exponent here is not something that we write down, but you need to know that it's there. And that is the exponent 1. It is a 1 there. And so if the exponent, the highest exponent is a 1, we call that a linear. You'll see the next part. So again, the highest exponent is 1. The highest exponent is 2, right? That's where we get those names from. Next, well, if you look at the pattern, the highest exponent is 3. That's called a cubic. So I can give you something like 5x to the 3rd power minus 4x squared plus 17x minus 8. Okay, that is a cubic because the highest exponent here is 3. Okay, so the next step, after 3 comes 4, and that's a quartic. So the highest exponent is a 4, and that can be something as simple as 5x to the 4th power, right? 5x to the 4th power, highest exponent is 4. It's the only exponent that we see there. Therefore, it's a quartic. What's next? A constant. Again, a constant is a number by itself. There is no variable. So I can give you something like 8. That's a number by itself. Now, attached to that, that means this variable, let's say I make one up for this problem. I said plus 2x, but the highest exponent is not 1 because then that would be linear. The highest exponent here would be 0. I'm actually not going to do 2x, sorry. Let's just do x. The highest exponent would be 0, and anything to the 0 power is 1. So therefore, this would go away, and all we'd have left is the x. So there's no variable around here. It's just the number itself, and so that's called a constant. All right, now you see I have an extra space on the bottom. That's because there could be more than 4 for the highest exponent. Now, in some books, they call a fifth one and the quintic, but I'm not going to go through that. Like, it depends on the book or the teacher. They might say quintic, but some people like to call anything higher than 4 an nth degree. And that's when you have an exponent greater than 4. So if an exponent greater than 4, I call it an nth degree. We do have an example for that later on, so we'll go through it then. The next part is the terms. Now, the backside of this, the nomial part of each of these words, nomial, means terms, right? And so we're going to count how many terms do we actually have. I like to see terms as my part. It is the section that is separated by either a plus or minus sign. All right. And so we'll give some examples of that. So when I think about the terms, I think about how many parts does this polynomial have? Well, the word mono, I'm actually doing a different color. The word mono means 1. So that means there's only one part. Okay, so one part. And what is an example of that? Something like 3x. Now you're like, hey, but that looks like 2 different numbers. Well, there's no plus or minus sign. So the parts are separated by a plus or minus sign. So if I see a plus or minus sign, that means I have a new part. And since there's no plus or minus sign separating these 3x, it's considered 1. So we call that a monomial. Here's an example over here. This quartic one, this 5x to the 4th, is a monomial because it's only one part, one term. So we call this a quartic monomial. Highest degree is 4, and there is one part. Quartic monomial. All right, next example. The binomial, like in the word bicycle, means you have 2 wheels, right? Bilateral, right? Those things mean 2. So bi means 2. So you're looking for something that has 2 parts. An example of this could be something like 6x minus 3. There's 2 parts, and they're separated by the plus or minus sign. Okay, what do we have over here? Looking at the linear function. The linear function has 2 parts, right? This is a linear binomial because it has 3x minus 4. Next, we have the trinomial. And again, that's 3. Tri means 3, like in tricycle or triangle. And so we have 3 parts. And so I'm not going to give you a numeric example, so I'm going to show you one soon. But again, we're going to look for the terms being separated by either a plus or a minus sign. Notice here I have 3 different sections. So let's look on this side. Where do I see something that's separated in 3 sections? That's right here in our quadratic. So I would call this polynomial a quadratic trinomial. It's quadratic because the highest exponent is 2. It's a trinomial because there's 3 parts. Last but not least is polynomial. Now, when I was younger, we used to have these toys called a Polly Pocket, and they came with a lot of different little pieces of toys, right? Poly means many, like in polygon, right? If you ever seen a polygon, we have all these different shapes. You can have square, a rectangle, a octagon, dodecagon, right? Those are all called polygons because they have many different sides. And so a polygon means many. That's when you have 4 or more different parts. So we can have 1, 2, 3, 4, or even more. Okay, 4 or more parts. Example over here is with our cubic. The cubic is a cubic polynomial because there's 1, 2, 3, 4 parts, and the highest exponent is 3. Okay, so let's go ahead and apply that. The rest of this, it goes about a little bit faster. So the first thing we're going to do is it says the directions say add the polynomials, but I also want us to pay attention to the sign right here in the middle. Right, there's a plus sign. So that means I'm going to add things together, and I'm going to look for my like terms, okay? Now, when I'm adding these, I can actually just go ahead and ignore the parentheses. I can go ahead and add together. So I'm looking for my like term, and I see that I have a 5. Oopsies. I have a 5x cubed and a 3x cubed. Well, 5 plus 3 is 8. I'm just counting them, so I'm not changing any exponents. It just says 8x cubed. How many do I have? The next like term that I see is this negative 3x and this positive 5x. Those are like terms. Negative 3 plus 5 is positive 2x. Now, what's next? I have this 2 left and this 2x squared. Those are not like terms, so I can go ahead and bring them down since it's only a positive sign. There's nothing going to affect those. And I'm almost finished, but here's the issue. We like things to be in a standard form, in proper order, and that means we count down from the highest exponent all the way down to our constant if we have one. So we need to change this thing into standard form by starting with the highest exponent, which is the 3, so 8x cubed, to the next exponent, which is the squared, plus 2x squared. The linear part of this, which is the 1, right, plus 2x, and then our constant here, which is the 2. Now it's in standard form. And now we're going to practice naming them. So our names come from the highest exponent and the number of parts. Our highest exponent is 3, and which is why we like to keep it in standard form. The highest exponent is 3, so this is a cubic. And how many parts do I have? Let's see. I have 1, 2, 3, 4 parts. So we're going to call this a polynomial, more than 3. Okay. Next one says subtract. So again, I know that that's what the directions say, but I want to get used to looking at our signs in our problem as well. There's a minus sign there. Now, I want to save time instead of having to put it back in order later on. Oh, just kidding. Let me go ahead. Now, it's because it's a subtraction sign. What I want to do is go ahead and distribute that minus sign to all my numbers on the right-hand side of the negative. So this left-hand side will stay the same. So 6x to the 5th minus 3x. I'm going to distribute the negatives. So that's a positive 4x to the 5th now. Distribute the negative. So that's a negative 2x. And distribute the negative, and that's a positive 5. And now, when I look for my like terms, I do want to make sure that I pick the like terms in order so I don't have to rearrange them later. So looking at this, the highest exponent I see is 5. So that's 6x to the 5th and 4x to the 5th, which is 10x to the 5th. The next like term I see that's the highest is just the x. So that's negative 3x minus 2x. Negative 3 minus 2 is just negative 5. And then I'm almost done. I only have one number left. That's our plus 5. And I go ahead and write that down. Now, because I distributed, I don't have to worry about signs anymore. Okay, so the highest degree I see here is this 5. Now, let's go back to our table. All right, we had constant, linear, quadratic, cubic, quartic, and then the nth degree. That's when the exponent is higher than 4. So nth degree, we're not going to call it n. We're actually going to call it a 5th because that's the highest exponent. It lets everybody know, hey, the highest exponent was 5 degree. How many parts do I see? I have 1, 2, 3 parts. So we're going to call that a trinomial. Next up. Now, when I look at this problem, I see that I have a negative sign and I have a plus sign. So there's a minus sign and a plus sign. Well, the first thing I want to do is get rid of that minus sign because it kind of makes things a little bit complicated. So the first one doesn't have anything, so I'm going to go ahead and bring that down. 5x cubed minus 2x plus 1. The next part, now this negative 2 is only attached to the second polynomial, or the second expression. So I'm going to only multiply it by the second expression. So negative 2x squared minus 4x. And then this positive, right, it's not going to change anything. So I'm just going to bring down the last expression. There we go. And now I'm going to go ahead and combine my like terms. And I'm going to go in the order of the highest exponents down. Now you could pause right here and try it out yourself. So I will push pause. Okay, hopefully you try it out yourself and you have 5x cubed plus x cubed, which makes it a 6x cubed. Next up, I see a squared, so I have a negative 2x squared plus 5x squared. That makes a 3x squared. The next one I see is the negative 2x, the negative 4x, and the negative 8x. So we need to be careful that we use all the different terms. We don't want to leave one out. Negative 2 minus 4 is negative 6, minus 8 is negative 14x. And then last but not least, we have that plus 1 at the end. Double check, did I include all my different terms? I did. So what do I have here? Highest exponent is 3, so this is cubic. There's lots of terms here, so we're going to call this a polynomial. Okay, last one. Go again. If you want to take a pause and make sure you do it, I'm going to do this all in one color, so now that you can try to do it our own and it matches. I'm going to, so pause. Okay, hopefully you paused it and you tried out yourself. And now you get to see, like, did I actually do this correctly? Did I distribute everything correctly? Because that's important. Can I find my like terms and combine it with the right ones? Cool. Now I notice I have a negative n squared and a positive n squared, right? Negative 1 plus 1, it cancels each other out. They're gone. And I don't want to write them if I don't need them. Okay, that's a waste of time. So if they're gone, if it's 0, we don't need to write it down. Moving on to the next one. And then 2n minus n is just a positive 1n or just n, right? You won't see someone write the 1. We like to write as less as possible. And then minus 12. And again, I have another cubic. That's crazy. So this is a cubic. I was supposed to write this without colors. Ha ha ha. A cubic trinomial because there's 3 parts. Cubic because the highest exponent is 3. And then trinomial, there's 3 terms. All right, well, good job, you guys. Thank you for joining me, and I'll see you next time.